Welcome class 221B. This is group 6 during lesson 22 quiz. Let's grab it. Just take a second, grab your files you need. Yeah, I can't imagine trying to do a class like this without having access to a computer.
For real, it would be impossible.
I mean, even if you tried to do it at a computer lab, it would still be weird.
Yeah.
Yeah, I see a few students who it looks like they don't have like their personal computer and they have to use computers on campus, and it just it makes me feel so sad.
It's one of those things where you had the money, you're like, here, just take this. It's a Dell, but whatever, take it. I mean, yeah, if I was gonna buy some computer, I probably wouldn't buy him like a Mac or something. But yeah, I would definitely not be opposed to buying like a Dell or something.
Yeah,
because some of those are okay. It depends on what you get.
Exactly.
Are you guys ready?
Yep.
Given a linear regression equation, y equals 2 plus 1.5x, what is the y-intercept?
2, right?
so you put 0 for the other equals.
Yeah, because you put 0 for x, I believe.
Yeah.
So it should be 2, yeah, because...
it's like super funny because like I was reading through it and I was like, wow, I remember doing this stuff when I was like in 5th grade. And then
5th grade? I did in 7th grade, but yeah.
Probably like, yeah, 7th grade. And then I was like, but it was like all like newish to me again. And I was like, whoa, this is weird.
Yeah.
So what is the slope?
This will need to transfer to slope-intercept form, correct? Or is it? Or no, it's 1.5. That's already in slope-intercept form.
Y equals 1.5x plus 2.
I get confused because there's like 2 different forms you can put it in.
It's just 1.5, right?
Yeah.
Slope-intercept, point slope, and standard.
Given a linear regression equation, y equals -3 plus 0.25x, what is the predicted value of y when x equals 16? So I'm assuming you guys can know how to do this. Just give me answers when you get it. It's actually quite easy. So I'm getting 1.
Yeah, 1.
Yep, me too.
All right. Okay, let's start putting our data in. All right, so it tells us what you use for which. So explanatory should be confidence data, and score data should be response variables. So make sure you put them in the right way.
I did a test, and it appears as though it doesn't really matter.
Well, I would assume it does at some point because it is a dependent thing. Well, I guess it depends on what data is.
Yeah.
All right, let's.
I would assume if they tell you to do it, it would be a safe bet just to do it.
Probably, yeah.
All right.
Matter more.
What shape are you looking at?
Like a hot dog?
That's what I'm thinking. Yeah, I'm thinking hot dog too. What about you guys?
Yeah.
All right. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using linear regression to model this data? I want to say B. I mean,
What can you say about the appropriateness? I mean, it does follow the line.
Yeah, no, it follows the line and it makes sense. So I guess you could say A, but it's enough. I don't know. I imagine if it was hamburger, it would probably be no.
Yeah.
But I think I would assume.
I think it would work.
Yeah, that's fine with me.
Yeah, I think they're going right along with it. Hot dog would be appropriate. Hamburger would be not accurate.
And banana would be unreliable.
Yeah.
All right. How many observations are in the data?
Does it give us?
I thought it did.
Would that be the DF?
Where's that at? I'm not even.
No, they didn't have that. That didn't exist. Sorry. Ignore that.
Is it this predicted number?
It'll be 138.
Huh. So it looks like there's like 142 of each. No, 100.
Minus 4. It's 138.
Yeah.
Is that what you guys are thinking?
In 1 second. Yeah, so I'm getting 138 of each.
Yeah.
So should we do both of them together or just 138?
I would assume it would. I would assume this would be 138 because they're basically pointing. They go together.
Yeah.
It's the same observation. Yeah.
Yeah. Okay.
And if we get this wrong, we can figure it out.
Intercept.
So what did you guys decide to go with? Sorry.
138.
138. Okay.
The y-intercept.
Is that 6 where X?
See, I totally.
Oh, here.
45.
There's a y-intercept model up in the second chart.
Oh. Oh yeah.
Wait, where at?
I'll share screen it. You're seeing it right here?
Oh.
Yeah.
So is it the unstandardized one? 690?
Well, I would assume so, but
Yeah, that makes sense.
Where can you point to it again, Brooks?
yeah, right here.
Yeah, I'm getting a different number for that.
What are you getting?
I'm getting 1.296.
What are you getting, Davis? 18.690?
I'm getting 1.296 as well.
I wonder if I did something wrong. Does mine look similar to your guys in terms of charts and stuff?
Yeah, it's the same one.
Ah, that's weird.
That is really weird.
Look at the textbook real quick.
Yeah. Can someone share screen there so I can see what the difference is?
I can.
Actually, move that up. Compare.
Did you see mine?
Yeah. Oh, wow. That's really different. Hey, Hey, what variable do you put for which? Because I switched my variables. My x is because I have my, if you look at my variables are flipped from yours because I'm using it from what it says in here. Where it says to for next 7 questions, you should use confidence data for explanatory variable and score data as the response variable.
So my first explanatory variable was 50. My first response was 4.34.
Are you sure that's right? Because confidence is supposed to be explanatory.
So maybe we do flip them.
Yeah.
I mean, that's what it says right here in the quiz.
Yeah. So that answered a question at the beginning because it doesn't affect a lot of these things, but it does affect the y-intercept.
Yeah.
Okay, so we'll just go with Brooks' answer then, I guess.
And that's okay.
Yeah. What was your answer then?
You see it, it's 18.690. I just assume because they told it to that way, you probably should follow.
Makes sense.
And slope, I'm getting 12.695.
All right.
What are you getting on slope?
12.695.
I see. Yeah. Okay. The predicted value of y when x is 4.
Do we have to go back to that equation? No.
Oh, you just change it. Do you guys see my screen?
Give me 1 sec.
It's this right here. It was 6.
Oh, okay, that makes sense. Yeah, that makes sense.
And it's a predicted, right? So it's going to be the 69.469.
Yep, I'm cool with that.
69 point, what was
469. 69.469, sorry. All right.
Okay, so the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. So what's the largest x?
It would have to, would it wouldn't be 6, would it? Or is it an actual 1?
What is the largest?
That's what I'm looking.
You could technically find the max on there.
Couldn't you like this do 6? This is maximum predicted value, and the highest you would be predicted is 6. Or are you talking about actual sample data?
I think it's talking about, I'm not sure.
Because if you're looking at actual sample data, the largest number is 5.93.
Is it? Okay.
I'm pretty sure I'm not seeing anything higher than that.
Probably going to be 93.970.
That's 5.93.
Yeah.
It was what? Sorry.
Under the x value, I put 5.93 because it's, so the predicted is 93.970. Does that seem right to you guys?
Yeah, that sounds about right.
Yeah, let's go with that. And if it's wrong, we'll try something else.
Okay. How many explanatory or independent variables are present in simple linear regression?
Just 1. Right?
Yeah.
Why?
I don't know.
Well, I think linear regression is simply a two-shaded chart.
So there's just the independent and the dependent variable.
Yeah, I assume that's the case.
Because one's the x-axis, one's the y-axis.
Yeah. So X is always going to be independent. Y is going to be dependent.
So you guys are thinking 1 then.
Yeah, I'm thinking it's sort of a trick question kind of thing.
Okay.
And I think it's gonna be 1 for the next one as well.
Yeah. I'll read the next question. A company in South Dakota manufactures hard hats used in the mining industry. They record measurement on all the hats they produce for quality control and planning purposes. The measurements they collect includes hat size, circumference of the hat, and length of the major and minor axes. Meaning the company wants to predict the size of the hat given the circumference. What is the response variable? I would say it's the size of the hat.
Yeah. Is the variable being predicted?
Yeah, I'll say it's A.
So you said it was A?
That's what I'm thinking.
Okay.
I'll take a leap here and submit it and see what I get. All right, the observation question is wrong, and the confidence data in our question is wrong. So 8 is incorrect. It's not 138. And 12 is incorrect. It's not 93.97.
Okay. So the 2 we were pretty unsure about.
Yeah. So does someone want to try doing 6 for as the X for question 12? I don't want to submit again until we're sure.
Isn't that exactly how many values there are on the Excel sheet?
Give me one sec. I'm going to share a screen my quiz.
I haven't flipped mine, so it's not going to work.
Okay, yeah, that's the same as mine.
All right, let me do it. And
6? You just want me to put 6 for the X?
yeah, I'm getting 94.859.
Yeah.
For 12.
Yeah,
94.859.
859.
And then 8 was the other one that we got wrong?
Yeah, that was the one about observation where we really weren't sure what we're looking at.
Let me look in the textbook real quick.
Yeah, that's what I'll do.
Interesting.
Hey, so you guys said you got number 8 wrong, right?
Yeah.
139. I just submitted it. I think we're just one number off, and so I got 8 right. That's
Oh.
139.
Did you get 12 right too?
No.
139.
0. My bad.
So what did you put for 12, Spencer? The same thing we did?
You got 139, Spencer, on 8.
139. Yes, I think we're just one short.
Okay.
And then what'd you put for 12 that you didn't get right?
I just don't know what you guys did, right? 93.970.
Okay.
All right, someone who hasn't submitted it yet want to try
94.859,
859.
yeah.
And make sure you change your 8 to 139.
100%.
All right.
Wait, so what did you say it was 12 again?
94.85.
Go ahead. To 94.859. Sorry.
Yeah.
Okay. I'm so sorry. What was the answer to number 7? Like, for some reason, Mark checked the wrong one.
It's A.
Yeah.
All right, we all good then?
Give me 1 second. I'm gonna test this real quick.
Good.
Yeah, we're good.
That was a pretty easy one.
Yeah, wasn't too well. The one before that was way easier.
No,
I did the group meeting quiz on my own, and like I did it in like 5 minutes maybe.
Yeah. Hey guys, be sure to look over that document I sent you. Just be really critical of it if you need to. I won't get offended. So
Yeah, so the plan is same time tomorrow. We'll talk just about the project. So again, everyone look over it, come up with you don't have to come up with it. It looks perfect, it's perfect. But if you see something you need to fix, you can either fix it or you can wait to the group meeting to address it. It's up to you.
Sounds good.
If it's like a grammar thing, I would just go ahead and fix it.
Sounds good.
All right. Stopping broadcast.